Welcome to my course in ozone technology. This is the 17th session of the course, and we will be discussing the current treatment of sewage in the community, state, or small home systems. The first stage of treatment will be to receive the sewage, which will be in the form of suspensions, and remove the insoluble material. The insoluble material generally consists of tissue, toilet rolls, paper, rubber, plastic materials, hair, it may be in clumps, cigarette stumps, baby wipes, nappies, and other materials that some people may throw in the loo. The removal is done in a series of sieves or grills that collected these insoluble material and filter them off as sludge. The clear suspended solution of sewage is then pumped into the first tanks. The tanks are called biodegradation tanks. The sludge that is filtered is collected and taken into a special sludge collection tank where it is dried and then removed for sterilization as soon as in stage 6. It is then sold as fertilizer or just taken to the landfill. The next stage, stage 3, is biodegradation or digestion. There is a long arm circulating around the tank which has mixer blades so that sewer water is continuously circulated and mixed. Aerobic bacteria may be added to supplement the existing bacteria. At the same time, these arms also have air pipes that will pump in hot air in the winter or normal air in the summer into the sewer system. This is to maintain the temperature in the system as close to 37 degrees centigrade, the best temperature that the bacteria will propagate. Alternatively, they may have a series of atomizers located at the bottom of the tanks that pump in air. The copious amount of air will induce the aerobic bacteria to work and break down the organic material in the sewage. If the air is precluded, then the anaerobic bacteria will take over and produces plenty of bad smell. Therefore, it is important that we don't want to produce the unwanted foul odors during the fermentation, and therefore the tank must be very well aerated. During the period, there could be also some settlement of undigested material that can be taken off as sludge. In stage 4, the treated sewerage through overflow flows into the treated water tank, from which it is directed after sterilization by chlorine either to be used as recycled water, which is shown in stage 5, or drained into the sea. In stage 5, the water is further chlorinated to ensure it's potable and can be used for recycled water distribution. And stage 6, it is a sludge collecting tank. It collects all the sludge, dries up, and the dried sludge is collected and transported for further treatment in packed bags and ready for garden fertilizer market. Please take the effort to view the following video. Thank you. This is a diagram, flow diagram of the current sewage treatment. As you see, the sewage comes in, it gets filtered through the grill, either the sieve, the grill. The filtered sludge goes straight into the sludge collection tanks for drying and is allowed to dry. And then the overflow water goes into each of the collection tanks, or where the biodegradation takes place. So the volume of this tank is related to the approximate volume of sewage that comes in per day from the community. In other words, if there is 1 million or say 1 megaliter or 100 megaliters of sewer comes in, then this gets filled up in 1 day. When this first tank is filled up, then the sewer is directed to the second tank. And during the filling of the second tank, there is degradation taking place with the bacteria which can be added, and it is totally aerated by either big arms or through atomizers at the bottom of the tank. Now it takes about 5 days for the complete aeration and destruction of all the protein matter, so that the water becomes very clear. And once the water becomes clear, the clear water runs off into the treated sewage water tank, while any undigested material, that is the sludge that settles down, is taken back to the sludge collection tank. When this degradation here takes place, the second day this gets filled up, the third day this gets filled up, the fourth day this gets filled up, the fifth day this gets filled up. By then, this tank will be emptied out so that the fresh sewage can come into this tank. The following day this gets emptied out, so this gets filled up and the sludge goes back into that. And therefore, using 5 separate tanks, they will be able to handle the sewage of the community. But if the sewage volume increases, then obviously they have to build more tanks. The sludge that comes from here, from stage 2 here, goes into stage 6. This is where the sludge is usually heated up or put into a very high temperature, so that all the bacteria, all the dangerous bacteria, all these are killed, and so that they can be packed up in bags and sold in the market. The water that is treated, there are 2 possible ways. The first is for the treated sewer to go back and can be pumped straight away into the sea, or it can be reused after further chlorination as recycled water. This is a part picture of a sewage treatment tank. If you notice that this tank, the coloration is a bit different from these 2 tanks. It's quite obvious this is collecting the fresh sewage sludge, sewage water that has just been filtered. And this is a tank that is being aerated, and you can see the bubbles coming up, and you can see the arm This is the arm that in both cases will spin, and that actually mixes the sewer to make sure it is all evenly distributed and aeration can take place. So this is the third tank. Obviously, from the look of it, there might be 6 tanks here, and depending on the volume of the tank, that will determine what is the total estimated output of the community. This diagram shows further in terms of visualization the sewer treatment process for the house. The treatment comes from a typical home. It is immediately the grits through the sieve removed, goes back into the primary settling tank. As you would have seen in the last slide, the sludge is taken back to the waste. It can be digested, and further, after the digestion, it can be removed. The clear water from this settling goes into the aeration tank, where there's even bacterial fermentation takes place, and the aeration also takes place, and goes back to the final settling tank. The sludge is removed, and the water from the tank is taken back, chlorinated, and sent it to the lake or the sea. The sludge is treated further. It could be by digestion until it is digested completely. The clear liquid is further pumped back into the system to be taken out to the sea. The dried sludge is pressed and dried and goes straight to the sludge disposal, probably to another place where it is further sterilized and used as garden fertilizers. In small and mid-sized sewer treatments, they might use the UV system to sterilize the water before they either reuse it as recycled water or drain it out in the sea. The typical UV system is shown on the right. The water flows into the inlet and it goes out to the outlet. So this is a UV tube that puts in the rays onto the flowing water, and it destroys or kills the bacteria. Obviously, there is a contact time for the killing to take place. So the movement from here to there must be sufficient enough for the water and bacteria to have in contact with the UV so that it can be destroyed. One of the important things using this method is, as you know, the water must be absolutely clear so that they do not deflect any UV and allow bacteria to pass through. Therefore, in many cases, they have to shut down and clean the tubes very frequently of any slime, dust, etc. that will reduce the penetration of light. Of course, if you use UV as like any lamps, it has got a limited life and it has to be checked regularly and replaced once the life is completed. This is done in the maintenance. In homes that do not have access to the communal sewage treatment system, they have this domestic sewage treatment systems which can be installed in homes where they have plenty of space. Now, one of the most important things in such treatment is to ensure that the treated sewer water will not be in contact with the groundwater, but it will have plenty of time for it to have complete digestion and removal of all the harmful bacteria. The sewage that comes out of the home is taken into a tank, which is called a septic tank, where again chemicals may be used that will either chemically digest the protein material, or they can use bacteria that will do the digestion. So on completion of the digestion, it goes back, is taken off, the supernatant liquid that is taken off will be drained through the gravel drain into the soil. So this will go through the porous pipes back into the soil and will probably used for as a fertilizer, and you probably could plant vegetables, etc. in this area. Now obviously the water sinks and will continue providing nutritional material for any vegetables that can be grown in this area. Now this is the figure or picture of the septic tank which is shown here. If you notice that as the sewer comes in, you have the effluent, and there will be a digestion taking place, either chemical or bacterial. So if there is bacterial digestion, obviously you have to aerate it. If it is a chemical digestion, of course there is no aeration required. Now, if in either case, if there is no bacteria and chemical aeration, then what will happen is the anaerobic bacteria will set in. The issue with anaerobic bacteria is that they will create awful smells that will come out of these excess rices and penetrate the environment. So it is very important either to ensure that there is aeration of this tank if it is used, if the biological fermentation is used, or if there's a chemicals are added, then aeration is not required. Now the clear fluid goes to the next stage and it is pumped out into the dispersal system as shown here. So this filter will ensure that it is clear water that goes in. Over a period of time, the sludge is collected and it will start increasing until it will interfere with the treatment systems, when you will have to stop the system, open up the excess and pump out the sludge effluent and restart the system. The approach in the previous system is ideal for homes where the existing landscape needs to be used and it's not possible to install the septic system in a nice open field. With a drip irrigation design, and the wastewater is pumped out into a network of pipes and channels buried under the ground at the levels of 8 inches depth. Please refer to this reference which I give you, that will give you some information as how this system works. The issues with the traditional sewage system are as follows. First, the biodegradation and digestion. Normally it takes 5 days for satisfactory completion. So as you know, subject to the volume it receives, and say 5 megaliters or 10 megaliters per day, the tanks must be allocated accordingly. Otherwise, there will be an overflow issues. The sanitation of drinking water standards, it's a bit difficult. There's a lot of chlorination that we use, but chlorination still is 99.9% kill, and therefore the remainder 0.1% may regrow upon standing and dissolve organic materials which are not removed in the treatment is used as food for the 0.1% of the bacteria to regrow and completely take over to high levels. So because of this issue, the liability of using recycled water for garden watering by the council has become a serious concern, so that they normally stop the process and get the water wasted into the sea. Thank you for watching my video. This is the end of session 17. Please proceed to session 18, which will continue with sewage treatment using ozone. If you are new to this channel, please refer to session 1 and 2 that will explain the course program, and 3 to 18 for sessions of the program. If you like this course, please tick the like icon and subscribe icon when you will be notified as soon as further sessions are released. Thank you and have a good day.